All right, looks like a few people are still trickling in, but I'm going to go ahead and get started. I'm going to do a bit of an overview of Akkio first, and then we'll get into a demo. And after that, we'll have a lot of time for questions at the end. So, but do feel free to pop your questions into the chat like midstream if you'd like, and I'll try to answer them as we go through the individual sections. So, nice to meet everybody. I'm John. I'm one of the co-founders of Akkio. The relevant area that I lead for this demo is the product management and directional team, where we decide how to build the product and how to make it work properly for our users. I also do marketing and support. If you pop in and ask a question in support, you'll probably be talking to me. But Akkio is built to solve sort of the long tail of business operations opportunities for machine learning. And so we're trying to bring all the benefits of machine learning to our customers without the learning curve that's associated with that, or the complexity that goes with learning to leverage ML in your daily workflows. So let's talk about what that looks like. We believe pretty strongly, and I think evidence continues to pile up for this, that someday soon, every part of every business is going to be run on machine learning. And many people inside of businesses are going to be using machine learning in their daily workflows. Today, machine learning is already a massive market, but it's primarily used by big enterprises with data science teams. And those groups are usually working directly on like the competitive differentiated edge of the company. So that's things like building machine learning into your product offering if you're a SaaS business and stuff like that. But where this is going, and I think we've seen this recently with the rise of ChatGPT, is that as machine learning gets easier to use and more accessible to people, more users in more businesses are going to be able to take advantage of it. And that's what we're building at Akkio, is a really easy to use platform that makes it possible for more and more people to use. I think it's interesting that GPT-3 came out way back in 2020, but it didn't really take off until ChatGPT came out, because finally there was a user interface that was easy enough for most of us to use. And since that came out, it's grown exponentially. Akkio is all about making it really easy to both work with your data and understand ML, and I'll show you a little bit about how we do that. But to get started, our main goal is to enable the 90% of workers within a company to use AI to solve 90% of the business operations problems. And the typical things we work with are things like employee retention, lead scoring, customer churn, forecasting, like prospect targeting, fraud detection, pretty much any application in your business operations where you can get leverage from your data. You can use a platform like Akkio to really quickly and easily understand the patterns that are driving your key outcomes, and then leverage that understanding to make strategic decisions, but also real-time decisions. I want to mention that everything I'll show you is built from the ground up to be enterprise grade. So we have full role-based access control built into the platform. We don't limit you on data uploads, and we don't limit you on training models or deploying models. And one of the reasons and we don't actually charge you on uploading data or flows or training flows or deploying models, because all of that is necessary to really explore the patterns in your data. And lots of times you have to iterate, or you might try and figure out a driving factor analysis that really isn't supported by your data history. And we don't want to charge you for value that you don't actually realize or capture. We have full built-in support, like a data engineering team that can give you on-demand support in experts in applications. And we also have priority support right through the chat window on our website if you need help. We do things like everything I'll show you in the user experience today is also capable of being accomplished via APIs. So if you need to do a lot of things in parallel, you can do that. If you want to call inference in real time, you can do that too. We have SOC 2 and HIPAA compliance, so we're quite secure. And then we also offer dedicated cloud configurations. So there's lots of security options. So Akkio is designed from the ground up to be able to work at enterprise scale. And we have customers using us on data sets that are 250 million rows deep. So, that's the way that we've built the company. If you don't know, there's Excel scale, which caps out at about 1 million rows. And then there's enterprise scale, which gets much bigger than that. We do the full stack of size of data sets. And we make it really easy to start getting really quick wins, sort of daily wins with bite-sized AI. And historically, machine learning programs and businesses have taken a really long time to go from data acquisition to data cleansing, all the way through analysis, and eventually a bunch of work on the operations and deployment side for the models. We're talking 6 to 8 months to get a model into production. And just like a complete user experience barrier for anyone who's not a data scientist to be able to surface data patterns inside of their data. We've built this to be ground up machine learning for your business. So the idea is, instead of these like really big high cost projects that take a really long time, you can dig in and get started in the small areas that you're working on in a daily basis. So think of this like machine learning for the rest of us. We make it really easy to do all of the things you have to do when you work with data. And we'll demo this today, but we make it about 10 times faster, sometimes more, to prepare your data or transform it in order to make it ready for analysis and processing. We automatically surface the driving insights inside of your data and show you aggregations of the shapes of your data. So it's really easy to tell what's going on. And then we make it like very, very simple to see how you could get leverage from a machine learning model, to think about how it might have value for your business. It's not always immediately intuitive, so we try and show you that in our insights report. And then of course, it's quite easy to deploy these models and make real-time business decisions whenever you're ready. So you can drop these models right in robotic process automation workflows, and off you go. It's worth mentioning that we've built our own next generation neural architecture search engine under the hood. That's the way we pick the ML model that's best to work with your data. And we've designed it to be both fast and accurate. This is just some benchmarking we did against some of the big players with complex to use auto ML tooling in the market. And you can see that we're both way faster and then more accurate on average than the rest of the competition. That's important because you don't want to spend a lot of time waiting around to see insights in your data or get results. And often working with data sets is an iterative process. So the quicker you can iterate through that process, the better. Okay, there's 3 main steps that I'll show you in this demo. The first is going to be connecting and preparing your data. It's worth noting that one thing we ran into in businesses before we decided to start Akkio is that the reality of your data environment is often pretty messy. I think this is quite typical across like all your data acquisition sources. Sometimes big data science driven machine learning projects have this issue where they clean and scrub the data until it's perfect, and then they train the best possible performing model they can. But when they turn around and use that model in the real world and with the messy data, it doesn't work so well because the real world data isn't scrubbed all squeaky clean. And then what happens is you have to kick off this data hygiene project. And I like to say data hygiene projects are where machine learning goes to die, because those are expensive and really complex to get right. Our philosophy and approach is that there's patterns and value in your data just as dirty as it is today. And you should be able to leverage that for value in your business. And then, of course, anything you do to clean up your data or make it more clean over time just yields you better results over time. But you can start getting value from machine learning today without those hygiene programs. The second step is training a model. That's where you pick your outcome of interest. Usually these are your business KPIs. And you feed us all the data you have that's relevant to that outcome. And we tell you which bits of it are driving which outcomes in which ways, so you can understand what's going to happen and why it's going to happen. And then, you can deploy these predictions right back into your data sources in a couple of clicks really, really easily. And I'll demo that today as well. Most exciting for today's demo will be Chat Data Prep, a new feature we just launched, which is a way of addressing one of the most painful and like longest pieces of the data pipeline, which is preparing your data. If you look online, people say this takes between 60 and 80% of their time getting the data into a format where you could actually do analysis on it. We make that way faster, so you can spend a lot more of your time actually working on deriving the insights in the data, helping the decision makers and make the right decisions, like setting up real-time workflows that automate pieces of your business that otherwise were like human hard. So we'll take a look at Chat Data Prep too. So that's it on the quick overview of Akkio. If you have any questions on that little bit, you can feel free to drop them in the chat, and I'm going to stop sharing really quickly and bring up my Akkio demo. Okay, cool. Hopefully everyone can now see my screen. This is the Akkio flow page, which is the first page you get when you create an account on our platform. I should probably mention that we have an open platform, so anyone who's on the call or anyone at all can go in and do a free trial, and we actually have a free tier that you end up on after the free trial where you can still train models. So I encourage everyone who hasn't taken the time to play around with us to do so. When you set up an account, we upload 6 or 7 different demo data sets, some of which are in here, so that you can have some data to play around with. But of course, you can just bring your own data and play around with that too. I'll start by building a regression model. I'm going to build an end-to-end model here and go through each one of the steps to walk you through them. Then we'll take a look at some classification insights and some time-driven time series forecasting as well. And we'll get to questions. So the first step here is pretty straightforward. You just click Create New Flow. The concept of a flow is an end-to-end machine learning model. So it does everything from data prep to insight generation to model deployment and model operations. And it all starts with connecting data. You can import data tables in CSV form, Excel, other formats there. And we also connect up to your CRMs, data warehouses like Snowflake and BigQuery, or even Google Sheets. We are adding more integrations here all of the time. So it's really easy to get your data from wherever it lives into the platform to begin analysis on it. In this case, I'm going to pick a property prices data set. So let me upload this really quickly so you see the full end-to-end process. I will go down here to property prices. And this is just a CSV, and it'll load in here in a second. And we'll see that this contains about 4,500 rows of homes that were sold in the Washington state region. And up here at the top, we sort of show you the row count and the column count. You can see we have things like the number of bedrooms, bathrooms, living square footage. If we scroll over here to the right, you can see we have the addresses, the cities, the states, and the country is all rows are US. And then we have the prices that those homes sold at. So the hypothetical application here would be to sort of do the Zillow thing where we would build a model to understand the patterns in the home like features that are driving the sales price, and then use that model to make some arbitrary predictions of downstream homes that are not yet for sale to understand what their likely prices to be. Okay, so once we upload the data, you'll notice what we did automatically was detect the type of information in each one of your columns. And that could be a bunch of different pieces of information. It could be an ID, it could be a category, it could be a number, it could be a date, or it could even be unstructured text, right? Like in this case, we have the street addresses. And we're able to use all of that information to do this task of detecting the patterns driving the prices of the homes. But the first thing that you might want to do when you get a data set in is do some transformations to the data set. And I'll show you some different transformations at some different places during the demo. But to start, this is chat data prep. And the idea of chat data prep is you can make a natural language ask of the data set, and it can be pretty arbitrary. And we will interpret that using a large language model on the back end. We'll convert it to code that operates on your data set at scale. And then we'll show you a preview of the transform that's going to be done on the data set so you can see if it got it right or not. We'll also describe how we interpreted your ask, because one of the things we found here is that a lot of times when you make an ask to transform a data set, you don't fully specify that ask all of the way through. I see we have a raised hand. So okay, so let's play around with this and see how it works. Let's say, for example, looking at this, there's some square footage of lot here, and you can click on any one of these, and we'll show you the correlations between that column and the other columns in your data set. So you can see the lot square footage is mostly correlated with your square footage of living area and the above ground living area and a little bit with your view. And let's say we want to like remove some of these like really big outliers over here on the lot square footage. Well, we can just, ask it to do something like remove all 3 sigma outliers from square foot lot. And that'd be a pretty complicated transform to do in Excel, for example, because you'd have to calculate the mean of the column, and then okay, you can see here we'd remove 1.7% of the rows, and we interpreted that to be any values that are more than 3 standard deviations away from the mean of the column will be removed. And we can just hit apply then if we like the value here, and you can see that we've now adjusted the distribution here so that the large outliers have been removed. And it's as simple as hitting apply, and we will remove 1.7% of the rows of the data set. And then we will be good to go. And each transform that we apply to the data set, we will redo the analysis on the shape of the data, and you will see that now the square footage of lots has changed, and the correlations may be modified a little bit as some of the rows are removed. You can also stack these, so we can do a second or a third like transformation if we'd like. At any time, you can come back here and click on the transformation that's done, and you can see what your input was, remove all 3 sigma outliers, and what our interpretation was. In case you need to like edit those or you want to delete the transformations that you've made, you can do so, right? And of course, you can just click over here on download and download that transformed data set. So if you have to do some complex stuff in Excel that you want to do a time shortcut on, upload the data set, do all the transforms you want with natural language, download the transformed data sets, and you're good to go. Let's look at some more possible transforms here just to give you an idea of sort of the range of capabilities. We can do something like combine all location info, something pretty underspecified. To get this one right, the model's going to have to figure out that street, city, state zip, and country are all location related fields. And it'll have to do a join action on all of them. If you were doing this in Excel, again, this would be a bit of a complicated formula. With us, like pretty straightforward, it actually decides that you don't need the information in there twice. You can delete the input columns, and you'll have a combined newly named location column. It came up with that name automatically on its own without us having to do anything. And we can simply apply that transformation to the data set if we'd like. You could see that when we show you the value for the AI interpretation, that you can clone this value back into your input. So if you find that your input wasn't interpreted in the way that you want, it's really easy to like clone over the more verbose description of what we're doing to the data set and just edit it to get to exactly what you're looking for. You can also do transformations like show me homes that are good for 2 roommates, stuff like this. And this one's pretty underspecified because any 2 roommates might have different requirements for what they're looking for in a home, but the model will do its best to interpret that request and come up with a filter that appropriately fits it. And this is a good example of where you might want to clone in the response. Hopefully this is going to work. Sometimes it takes a little bit. Okay, so our interpretation on that one is a home that's good for 2 roommates. Would be 2 bedrooms, 2 or more bathrooms, and a square footage living area greater than 1,000. And if you wanted to edit that request, it's easy enough to copy it over. And let's say 1.5 or more bathrooms, and off you go. I think everyone gets the idea. You can also do things like, I won't let this one complete. You can do things like write a summary of each home. And this is a good example transformation because it'll give you an idea of like where there are some limitations in the platform. So right now, all data transformations are applied like data set wide programmatically. And the important thing to remember here is if you do something like write a summary, we're going to do that for you, but that summary is effectively going to be the same for each row. It's not going to be a unique summary per row. So it doesn't work quite like a programmatic language generator. We're more taking the data that exists, combining it with a summary field, and then applying that to every row in the data set. And that's necessary for this to operate at scale outside of like the 100,000 row range, right? Because right now the APIs for these large language models are too slow to support million or 100 million row data set augmentations on a line by line basis. But that's certainly coming as these models get cheaper and faster to apply. Okay, cool. That's the, I have another Q&A here, so let's take a look. There's a question we'll answer in a little bit, or one of the folks can jump in and help out with that one. Okay, cool. So I'm going to remove the location consolidation here for the next step, because we're going to see some interesting patterns in the data. So once we're happy with the shape of our data generally, what we have here is a numeric prediction problem, right? So our goal is to predict the price of future homes and understand the relationship between the inputs and price. So to do that, we will just add a next step, and we'll click this predict button down here. Predict is the button that works on categories and number outcomes. If you have a time-driven outcome, and we'll visit these in a second, you can click forecast. We can also detect anomalies, which will be ranking all of your data from more similar to least similar. And that can be helpful for surfacing garbage data if you have it, or outliers that you might want to take a look at in data sets. But we'll just click predict. And then from here, it's pretty straightforward. You can pick any one of those columns as your outcome of interest. In this case, it's price. So you simply select price. You can also pick any columns that you'd like to ignore. So you can just click over here and ignore. And if we don't care about the house ID, and actually the house ID wouldn't be used to predict anyways, because IDs are unique and there's no patterns in them. You can just ignore any input fields that you like that aren't relevant, or maybe that happen after your prediction target in time. And then you just click create predictive model. It's that easy. Now what we're going to do in the background is all of the heavy lifting on the data science side. So we're going to encode every one of your columns in your data set with a proper encoder for the type of information that was in that column. And then we're going to do an 80-20 split on the data, very standard. And we'll bootstrap the model in our neural architecture search engine, finding the best performing model for your particular data on the 80% of training data. And once we find that best performing model, and I'm doing it on the fastest training mode for the purposes of this demo, but you can set the training time to longer and sometimes get a little bit more accuracy out of the model. We will then take the remaining 20% of data and we'll run it against the model that we picked, so you can get an idea of how good that model is at actually predicting the outcome and how strong the pattern recognition of the model was. So if you bear with me here in just a second, we are evaluating the model, and then we'll generate a bunch of insights about the patterns in your data. And this is really the first real payoff as you're using the platform, because this is where you get all of the information you need to understand why things are happening in your KPIs. Okay, so we're making sample predictions now against the data set. Actually, the graphic here is reasonably connected to the actual structure of some of the architectures we're trying in the background. So that's unique to every time you train. And we're calculating the insights here really quickly. And in a short period of time, we'll be able to take a look at what the model did. Okay, so right away at the top, we can see that we've predicted price, which is a number. This report is called the Insights Report, and it can actually be shared with anyone you'd like just by clicking this link, and we'll open up a dedicated web page for it. So if you want to share the insights about patterns in your data with anyone in your business, we make that really easy. But let's take a look. So in the withheld portion of the data, our accuracy and price is usually within 16.6%. And the first thing you need to ask yourself is that good enough for my application? And in this particular case, we only had 4,500 examples of property prices that we used, and we trained on only 80% of those. So we don't really have a lot of historic examples. We're usually within $90,000 to actual. And you can drill down here and see how well we recognize the pattern. So the dotted line is like if the predicted and the true value were exactly perfect. And you can see we did a pretty good job of learning the pattern of relationship between the input variables and price. But there's still some uncertainty there. We're usually within 16%. So depending on your application, you may need to go get more historic examples in order to get to an accuracy that's worthwhile for what you're going to do, or you might be able to extract value from this as it is. Every time we show you a value like mean absolute error, we describe it over here for you. So it's really easy to understand if you're not familiar with some of the terms. And you can even drill down and look at the loss graph and see that we picked a sparse neural network for this particular application. Those are for more advanced users typically, but it is interesting to take a look at your performance details on the regression model to see how clearly the pattern's emerging here, which is we're doing pretty well. The next thing we do is we tell you which of the input fields are most predictive of your output value and price, and in which ways they matter. So if you'll remember, street was a text field. And so we started extracting things like the word Mercer, Northeast, Way, and Washington from the fields. And city, for example, was a categorical field. And same thing. So you can see Bellevue is associated with a $104,000 increase in price, and Auburn down here on average minus 63K value in price. And you can look, at the basement square footage, your square footage of living area, and all of these make sense, right? Smaller living square footages are associated with lower prices. Higher living square footages are associated with higher prices. So this is the first place where you start to see the driving factors in your data. And then we'll actually show you factor by factor. So, the number one individual indicator of impact on price is square footage of living, and specifically large square footages of living, which is the dark blue color in this graph. For square footage of living that are in the 2.7K to 10K range, that happens about 20% of the time in your data set. And on average, those homes are priced 236K higher than the average price in your data set. So you get a sense of the delta here and the frequency at which that occurs. And you can drill down and see, like, every one of these, the above ground square footage is very similar to that. And here's what happens on the smaller side of living square footage. And you can see your basement's square footage as well and how that matters and plays into your outcomes. We also automatically create segments. And we use a language model to label these segments so you can understand them a little bit. But it looks like Mercer Island is one of the most expensive areas in the Seattle region, or in the Washington state region. And the average price of homes there is $834K. About 34% of our data set fits this segment. And then we show you what the densification factors or similarity factors were for that segment. And these segments are arrayed along the outcome of interest, right, which is price. So, they're 3 times more likely to have this zip. They're 3 times more likely to be on Mercer Island. They're 3 times more likely to have 2.5 floors, 2 times more likely to have 6 bedrooms, and 1.4 times more likely than average to have a condition of 5. We can go over here and look at the low priced ones and see Des Moines looks like it's 5 times more likely. It doesn't occur all that often, but it's not an expensive city. They're 3.5, 4 times more likely to have a single bedroom, be in worse condition, and only have a single floor. So all these values make sense, right? And they help you sort of understand the natural groupings in the data by price. And then at the bottom, we show you some sample predictions. So you can go and see how we did, where we got it right and where we got it wrong, and how much we were off by in the withheld portion of your data set. So that's the insights report. And its real goal is to show you what's going on in the data that's driving your outcome, and help you understand, like, how you could optimize your strategic business decisions to optimize that outcome. Or in this case, if you're buying a home, maybe where the right city fit for you or the size fit might be given your budget, right? But let's say we want to deploy that model and use it in real-time decision-making. Well, that's as easy as another couple of clicks. Like I said, everything that we're going to show you can be accomplished via API, from uploading data to training models to calling inference. But you can also just deploy a web app. You can push the predictions right back into your data stores and set them to run at whatever time you like. I'll click web app for the purposes of this demo, because this is an easy way to see how we do inference. In one click, I'll hit deploy. And now we have a live endpoint for that model. And we picked the fields that were most important in driving the outcome here for you automatically. So we can come in and do things like put in a 1,200 square foot lot on a 1,200 square foot with 1,200 square feet of living. So place with no yard with a condition of 4. And we'll leave it we'll leave a bunch of other blanks because we're robust to messy data. With that little bit of information, it thinks the home would be something like 350K. But we can come over here to the city, and let's say that same home was for sale in Bellevue. And we can see that the price goes up, right? Because Bellevue would be one of the more expensive regions in Washington. And I believe if we change this to something like Auburn, like we saw, which is one of the less expensive regions, we should see the price go down. And we do. So you're able to interrogate the model in a really natural way. By the way, you can also bulk predict on the web endpoint. So if you have an Excel file or a CSV that has all of those input values, but no home prices in it, you can just drag and drop it into this screen and we'll fill in all the predictions for you, no problem. So that's regression and chat data prep in an end-to-end way. But I'm going to show you another couple of model types because I think they're interesting and worth discussing. We'll take a look at a classification model that predicts churn within a telco. So here we have a bunch of different customers of a telco in Europe, I believe, the services that they're using, how long they've been a customer, and what type of billing that they use, and then whether or not they churned in the last couple of months. And the goal here would be sort of the same, to figure out what the features that are in the data that indicate that a customer is likely to churn. In this case, we only have two outcomes. It's not a number, it's a category, so that's a classification problem. I've already trained this model, so we don't have to sit around and watch it train again. I trained it on the fastest mode as well. But I think this is instructive because it helps you think through how to get leverage out of a model. So this model is only 80% accurate at predicting whether or not someone will churn. It caught 204 out of 372, so 55% of the true positives. It thought 103 people would churn who didn't, right? And you can see the details again in the model information if you want down at the bottom. So the question that a lot of people have at this point is 80%, that's not particularly good. Is there business value in that model? Well, the reality is it really depends on your densification of class. So when we predicted that someone was 50% or more likely to churn, they did so at a 2.5 times more rate than the base. And so that's actually where the leverage in the model comes into play. If you know that someone is 2.5 times more likely to churn than average, that's a place you might want to take intervention. And as we get through the top fields and work our way down here in the insights, you're going to see how we can look at the probability of outcome to start setting some thresholds in decision making for the model. And I think that's an important way to leverage ML in your business. So let's get started. You can see here total charges. We'll look by positive impact. You can even look at these in a magnitude sort of view. So it looks like if your charges are on the low side, you're more likely to churn. If they're on the high side, you're less likely to churn. Electronic checks are more likely to churn. These may be really tech forward people who are cross shopping. Keep in mind, this is a telco in Europe, so there's a lot of competition. If you don't have online security, you're more likely to churn than if you do. And if your monthly charges are again low is negative, or actually in this case, most positive impact. Let's go by lowest factor. Positive impact. Yeah. Okay. So low values a little bit more likely than high values. And you can see how paperless billing matters. Tenure, the people who haven't been customers for more than 6 months, I believe, are much more likely to churn than people who've been customers for a long period of time. Again, we do segmentation for you. So, you're likely to churn people are the people not using your security service who use e-checks. So call those unprotected e-checkers. And your less likely to churn people are your high spenders. And apparently they're often using their credit card as their payment method, and they're not even using your internet service. So you might want to sub-segment this based on the type of services you offer if this were your actual application. Let me just check the question really quick. Okay, cool. All right, quickly, let's look at the this is what we call the decision threshold graph. So every time we make a prediction, we don't just tell you the class that we think it is, we tell you the probability that we think it's going to be in that class. So over here at the right, if you were 70% or more likely to churn in the model, if you were 70% or more likely to churn, 80% of the people in that bucket actually did churn. So that's a pretty good densification. Whereas over here at the left-hand side, if you're 6.3% or less likely to churn, 95% of those customers didn't churn. So how would you use this in your business? You'd look at the probability of outcome, you'd look at the clustering and the similar features between the users, and then you'd take action to try and get the people up over here that are likely to churn to look more like the people over here that are less likely to churn. And that action could be anything. It could be changes to your product offering, it could be pricing, it could be promotion, it could be trying to get people to pay in a different manner. Any one of those things that could drive your outcome in the way you're looking to have it happen. So that's a classification insights report. And then one more type that I'll show you is forecasting. And forecasting is one that we run into a lot, and is actually one of the hardest things to do with data. So let's look at something that's actually pretty complicated, the climate in Delhi. And what we have here is a data set of temperature, humidity, wind speed, and pressure for Delhi from 2013 to 2017. Here, like one of the cool things that I wanted to show you about chat data prep is you can do things like restate or reformat the date to month, day, year. Let's try that. Makes it really easy to change your date format from any format you have to a standardized format in a couple of clicks of the keyboard. So let's do that with these dates. Cool, you can see that would work and they would all be restated correctly. And you can do that across any sort of data inputs. We can do things like convert mean temp to Fahrenheit. And I'm not even gonna write out Fahrenheit. And it'll look at this mean temp and it'll do the math to convert it to Fahrenheit. One actual limitation here that's worth noting is if you try and do something like a currency exchange, the large language model will try and tell you what the exchange rate is, but it's been trained on a little bit out of date data. They're always a few years or a few months out of date. So you'll have to enter any real-time information yourself to do the calculations if you need it. It's just worth mentioning. So you can see we could do all of those transformations that you might do with dates. You could even calculate the days to today from date. And it should calculate the number of days that have passed since that date till today. All sorts of really easy, fast chat data transforms. We'll just let this one go through so you can see that it works, and then we'll go take a look at forecasting. Cool, so those were 3,690 days ago. I'm not gonna apply that because it'll make me retrain my model, but let's take a look. So in the case of a forecast, we're forecasting here the mean temperature, and what you get is your history, which is the green, and that's the data history of the temperature in Delhi. And then you can see the blue is the forward forecast period, and you can even turn on a confidence interval to give you a sense of how sure we are of that prediction on a forward going basis. One thing we do is we train two models actually. We train a model that only learns up to the last 20% of your data. So it uses 80% of what you give us. And then we forward forecast the most recent 20% of your time. And then we show you how that forecast did against your actuals. So you can see here, the prediction is the blue and the ground truth is the gray. And we're usually within 4.6%, which is pretty good for this data set. And it's interesting, machine learning is really good at finding complex repeating patterns in your data. This one in particular, I've aggregated the data to weekly. We can even take IDs that are threaded together. So let's say you have 5 different, let's say you're doing a song application where you have a bunch of tracks on Spotify and how often they were played. You can actually take each sequence and forecast them individually as well as the aggregate play count by grouping by ID in the ID field. This forecast doesn't have that feature to it. And then we show you driving factors that are time dependent, right? So on a monthly basis, January is associated with a negative impact in mean temp. June and July are the hottest months, right? Makes sense. You can also see wind speed. Here's the past wind speed in the last 20 days and what its future next 20-day impact is likely to be on your mean temp. So you can look at time-driven factors, what's happened to them recently, and what the expected change going forward from them is on any forecast. So we make forecasting very easy to do as well. And thank you all for attending. It was great to have you, and hopefully you learned something.